Hello, hi everyone. So, welcome to the class. Hello, hi everyone. Welcome to the class. This is your Shiva sir. Today we are going to discuss about scalars and vectors. Scalars and vectors, grade 11 topic. Grade 11 topic. So, very important. Very important. So, motion in a plane, motion in a straight line. So, wherever, okay. So, in all the cases, these points we will use. These points are using, okay, scalars and vectors. So what is scalar, what is vector, so what are the things and how it is. There are many points are there, so there are many points. Today we are going to discuss all those points. So okay, be ready for it, be ready for it. So now we are discussing about scalars and vectors. Scalars and vectors. So normally if you go to shopkeeper, so if you go to shop and ask, so I want rice and I want dal, I want like sugar, I want like something you. So whatever you ask, immediately the shopkeeper will ask you one question. Immediately will ask. So what is that question? So how many kgs you want? Okay, how many kgs you want and for how much you want? That's the first question. And if you ask chocolate, okay, so same question. How many you want for how much you want? Okay, so you want some snacks like that. Okay, same thing, same question. So it tells the answer for how much or how many. That is called quantity. Quantity is nothing but it tells the answer for how much or how many. Quantity is nothing but quantity. Okay, so quantity tells the answer for how much or how many. How much or how many. Okay, so 1 kg, 2 kg, 3 kg, 4 kg, like that. So it tells the answer for how much or how many, or it amount, vastness or magnitude. Amount, vastness or magnitude is called quantity. Okay, and the second one is physical quantity. Second one is physical quantity, right? Physical quantity. Physical quantity. Understood? So physical quantity. What is physical quantity? The quantity which can be measurable. The quantity which can be measurable is called physical quantity. The quantity which can be measurable is called physical quantity. So I said quantity, it tells the answer for how much or how many. It is amount or magnitude or vastness, like this we can say. Physical quantity. Physical quantity is nothing but the quantity which can be measurable. The quantity which can be measurable is called physical quantity. Best example, mass. Okay, so 2 kg, 3 kg, we can measurable, right? We can measure. So if you are taking this weight of the marker and the weight of the book and weight of the table and like this, so different, right? So weight of us also, like that we can say. So it can be measurable. So the quantity which can be measurable is called physical quantity. Physical quantity. Understood? So here there are two types. So there are two types of physical quantities are there. So one is so there, if you go to the quantities, there are many: fundamental physical quantity, supplementary physical quantity, derived physical quantity. Fundamental quantities are, those are basic quantity. Okay, length, mass, time, thermodynamic temperature, amount of substance, luminous intensity. So like that, there are 7 fundamental physical quantities are there, and units and everything. Okay, and the next one is derived supplementary physical quantities. Supplementary physical quantities, so like plane angle, solid angle. And coming to the derived physical quantity, the quantity which can be derived from the remaining remaining physical quantity like fundamental physical quantity and like a supplementary physical quantity. Those are derived physical quantity. Suppose density, if you take mass per unit volume, so that is a derived physical quantity. Understood? These are the fundamental physical. These are the physical quantities. Physical quantity types: fundamental physical quantity, supplementary physical quantity, derived physical quantity. Okay. So we are coming to the particular point, that is scalars and vectors. Okay, so today our topic is scalar and vector. What is scalar? What is vector? What is scalar? What is vector? Understood? So scalar is nothing but the physical quantity which has only magnitude. The physical quantity which has only magnitude. Like if you suppose, if you consider 1 gram, 2 gram, 3 kg, 4 kg, 5 kg, 6 kg, 7 kg, 8 kg, like that. And so 1 liter, 2 liters, 3 liters, 4 liters, like that, only magnitude is there. Magnitude. So the physical quantity which has only magnitude, if you want to represent particular physical quantity, if it is magnitude is there, that's enough. That is scalar quantity. So example, coming to physics related terms, if you say like especially topic wise, distance, like speed, density, mass, like this, these are the scalar quantities. And coming to the vector, so what do you mean by vector? Vector is nothing but the physical quantity which has both magnitude and direction. The physical quantity which has both magnitude and direction. Okay, so then that is called vector quantity, vector physical quantity, the physical quantity which has both magnitude and direction. So suppose we can take displacement, velocity, force, acceleration. Okay, like this we can say. Those are vector quantities. So coming to the vector physical quantities, there are different types of vectors are there. Okay, so there are different types of vectors. So we'll discuss all those things. First one, so I hope it is very clear. Quantity, physical quantity, types of physical quantities, fundamental physical quantity, derived physical quantity, fundamental physical quantities, derived physical quantities. Understood? I hope it is very clear. All those points we discussed. So now we are completely discussing about types of vectors. Those are, first one is equal vectors. Second one, negative vectors. Coming to the zero vector, zero or null vector, equal vector, zero or null vector. Okay, so coming to the third one, unit vector. Next one, fourth one, orthogonal unit vectors. Orthogonal unit vectors. Coming to that, so fifth one, so co-initial vectors. Sixth one, collinear vectors. And coming to the seventh one, coplanar vectors. And eighth one, understood? So localized vector. Next one is non-localized vector. Localized vector. And coming to the non-localized vector. Okay, non-localized vector. Sorry, here fourth one. This is 4, 4, 5, 6, 7, 8, 9 and 10. Non-localized vector 4, 5, 6, 7, 8, 9, 10. Non-localized vector. Null localized vector. Okay, non-localized vector. Understood or not? So these are the vectors. These are the vectors. Once again check here. Equal vectors. The vector whose magnitude, the vectors, if you are taking two vectors equal magnitude, two vectors having equal magnitude and are acting in the same direction. Same direction, those are called equal vectors. Okay? So equal vectors. So suppose if you are taking these two vectors, magnitude is same, at the same time both are having in the same direction. Both are acting in the same direction. Negative vectors. So vector magnitude is same but acting opposite direction. So negative vectors. Vectors are having same magnitude but acting opposite direction. And coming to the zero vector. The vector whose magnitude is zero. The vector whose magnitude is 0, that is called zero vector or null vector. Null vector. So zero vector. Next one, unit vector. The vector whose magnitude is 1, that is called unit vector. Okay, suppose if I am taking a vector, so I'll write one vector. Suppose a bar equal to ax I cap, ay j cap, az k cap. Okay, so we can take 2i cap, 3j cap, 3k cap, like that also we can take. Okay, so unit vector, the vector whose magnitude is 1, the vector whose magnitude is 1, that is called unit vector. Unit vector, I hope it is very clear. Unit vector, understood? Once again, equal vector, the vector whose magnitude, so the vectors having same magnitude and at the same time acting along the same direction. Equal magnitude at the same time acting in the same direction. Those are called equal vectors. Coming to negative vectors. Magnitudes are same but acting opposite direction. Those are called negative vectors. Coming to zero vector. The vector whose magnitude is 0. The vector whose magnitude is 0, that is called null vector or zero vector. And coming to the unit vector. Unit vector is representing the vector whose magnitude is 1 unit. Okay, so 1 or magnitude is 1. That is called unit vector. So a cap is, so unit vector can be represented a cap equal to a bar by mod a bar. So a bar is ax I cap, ay j cap, az k cap, and also we can take 2i cap, 3j cap, 4k cap, like that. So 2i cap, 3j cap, 4k cap by mod, you can take root over 2 square, 3 square, if it is 4 square, like that. According to the vector you can take. And coming to the orthogonal unit vectors. Okay, so the unit vectors acting along the orthogonal axis. So suppose if you are taking x-axis, y-axis, z-axis, so this is x-axis, y-axis and z-axis. Along x-axis I cap, along y-axis j cap, along z-axis k cap. Okay, these are the unit vectors. Unit vectors. Along x-axis I cap, along y-axis j cap, along z-axis k cap. These are the unit vectors acting along orthogonal axis. And coming to the co-initial vectors. So this is orthogonal vectors. Co-initial vector. Co-initial vectors is nothing but the vectors whose initial point is same. So a bar, b bar, a bar and b bar. So vector whose initial point is same, those are called co-initial vectors. Okay. So starting point is same. Starting point is same. That is called co-initial vectors. Coming to the collinear vectors. Vectors are acting, so either magnitude is same or not, it doesn't matter. If those vectors are acting in the same direction, then we can say collinear vectors. So in the same line, so those are called collinear vectors. Coming to the coplanar vectors. Coplanar vector. The vectors are acting in the same plane. The vectors acting in the same plane. Those are called coplanar vectors. Coplanar vectors. So coming to localized vector. The vector whose initial point is fixed. The vector whose initial point is fixed, that is called localized vector. Coming to non-localized vector, the vector whose initial point is not fixed. The vector whose initial point is not fixed, that is called non-localized vector. Non-localized vector. I hope it is very clear. Once again, we will discuss all those points. So equal vectors, both having equal magnitude at the same time acting in the same direction. Point number 1. And coming to the point number 2, negative vectors. So vectors having same magnitude but are acting in the same opposite direction. So vectors having same magnitude but acting opposite direction. Okay. So next one, zero vector. The vector whose magnitude is 0. The vector whose magnitude is 0, that is called zero vector or null vector. And coming to the unit vector, the vector whose magnitude is 1. Magnitude is 1, that is called unit vector. Unit vector can be represented with a cap. So if you are taking any vector, b cap, c cap, d cap, e cap, so like that, so and so. If you are taking vectors, so if you are mentioning the cap, that is unit vector. So that is a cap equal to a bar by mod a bar. A bar is a vector, mod a bar is the magnitude of the particular vector. Magnitude of the particular vector. So a bar is axi cap, ay j cap, az k cap. Okay, so instead of that we can take 2i cap, 3j cap, 4k cap, like that we can say. So I will explain this one, how to find out the unit vector. So with a few examples, 2 or more examples, we can take and do it. And coming to the co-initial vector, orthogonal vectors, orthogonal unit vectors, the vectors acting. So the unit vectors are acting along the orthogonal axis. I cap along x axis, j cap along y axis, k cap along z axis. Those are unit vectors. What are the unit vectors? I cap, j cap, k cap. So these are the unit vectors. I cap is a unit vector along x axis. I cap is a unit vector along x axis. J cap is a unit vector along y axis. K cap is a unit vector along z axis. So these are the unit vectors are acting along the orthogonal axis. Understood? Coming to the co-initial vectors. So the initial point of the vectors. Okay. So the two vectors having same initial point. That is called co-initial vector. Collinear vectors are acting in the same direction, in the same line. You can say in the same line. And coplanar vectors. So the vectors which are acting in the same plane. So xy plane, so yz plane, so like that, so on. Okay. So according to the plane. And coming to the localized vector, the vector whose initial point, so the vector whose initial point is fixed, that is called localized vector. The vector whose initial point is not fixed, those are called free vector. We can also free vector, non-localized vector or free vector. Okay. So these are the types of vectors. Understood or not? So now we will discuss about okay, addition of vectors. Let's start addition of vectors. Dun, 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 dun. Addition of vectors. Addition of vectors. So coming to addition of vectors, one is triangle of vector, triangle, parallelogram law, addition of vectors, addition of vectors, addition of vectors. One is triangle law, triangle of vectors. Second one is parallelogram law, parallelogram law of vectors. And coming to third one is polygon law of vectors, polygon law of vectors. Understood? So we will discuss about triangle law, polygon law and parallelogram So all those things we'll discuss. Let's start. Addition of vectors. So first we will discuss about addition is nothing but simply adding the vectors. Simply adding the vectors. We know that. So 2 plus 2, 3 plus 3 we can add. Okay. So 2 plus 3, 5. 3 plus 2, 5. Okay. So if you are adding the vectors, it will be different. But so adding so a bar, you are adding minus b bar, then that is a subtraction of vectors only. Addition, so negative vector if you add to the positive vector, that is subtraction only. Okay, so now we will discuss about it. So triangle of vectors. What do you mean by triangle of vector? Triangle of vector. So it is in the form of additional triangle of vector. So triangle of vectors. So what is that? So if you are taking two vectors are acting along the two sides of the triangle, and the third side is the resultant of the two actors. So I am taking A bar and B bar. Every time I am taking A bar and B bar, these are the two vectors. Those two vectors are acting along the two sides of the triangle. So I am taking this is A bar. Okay. And I am considering the B bar. This is the B bar. And along this third sides, if you are taking, this is the resultant of the vector, that is C bar. That is C bar. So C bar equal to resultant equal to A bar plus B bar. A bar plus B bar. Understood? So I am taking one more. So this is one vector. This is one vector. So like this direction, I am taking this direction. Now you can observe A bar, B bar and C bar. So which is the resultant? C bar, because A, B both are acting in the direction, C bar is the resultant. That is opposite of, so both remaining two vectors. So that's why C bar equal to A bar plus B bar. A bar plus B bar. So C bar is the resultant. C bar is the resultant vector. So you can see, so B bar is acting like this. C bar also acting like that, but resultant. So C bar is acting opposite of these two vectors. So A and B. So like that. So I will draw 2 or 3 diagrams and let me know the resultant. So resultant, you can, so I will take different, okay, so different vectors. Different vectors I am taking, just check once here. So here I am considering, so like this and like this, and the resultant, so if you are taking, so I am considering like this. So this is the direction and this is the direction, this is the opposite direction. So I am taking, so suppose L, M and N. Okay, which one is the resultant? M bar. M bar is the resultant vector because N bar is moving like this, L bar also moving like this, but the resultant M bar is acting opposite. M bar is acting opposite. So that's why we have to take resultant, that is M bar equal to L bar plus N bar, like this. This is the resultant. Okay. So and one more vector. So you can see. So like this I am taking. Okay. So this is so A bar, B bar, C bar. So which one is the resultant? So here you can observe A bar and C bar acting in the same direction. So like this. But B bar is acting opposite. B bar is acting opposite. So that's why B bar is the resultant vector. B bar is the resultant vector. Understood or not? Check once. So A bar and C bar acting in the same direction, but B bar is acting opposite direction. Opposite direction. Understood or not? So now B bar is the resultant. B bar equal to A bar plus C bar. A bar plus C bar. Okay. Suppose how to add the vectors. So I will give one example, then you can try. Okay. So I am giving A bar and B bar. So A bar is 2i cap, so 3j cap, 4k cap. Okay, so B bar is, So 4i cap, 2j cap, 3k cap, 3k cap. Okay. So I want a bar plus b bar. I want a bar plus b bar. So how to add the vectors? Simply add I cap plus I cap, j cap plus j cap, k cap plus k cap. You have to add like that. Understood? So 2 plus 2, 6 I cap. So 3 plus 2, 5j cap plus 7k cap. 7k cap. Even so, if I'm taking a bar equal to 6i cap plus 7j cap plus 8k cap. So b bar equal to, so suppose I'm taking 2i cap and 4j cap minus 3k cap. Even minus if it is there also, simply you can add. That's enough. That is a bar plus b bar equal to, so 6 plus 2 I cap. So then plus you can take 7 minus 4 j cap plus 8 so 8 minus 3 k cap. Okay, so numbers. So numbers you have to subtract. So the sign must be taken to the number. Okay, numerical value. You have to consider that sign to the numerical value. Then so how much? 8i cap plus 3j cap plus 5k cap. Understood? So that is a bar and b bar. I hope it is very clear. Understood or not? So next one. So we'll discuss about, normally just for showing that one I mentioned how to add. So now we will discuss about parallelogram vectors. Parallelogram vectors. Parallelogram law vectors. Parallelogram vectors will discuss. So you can see parallelogram vectors. Okay. So now you can observe two vectors are acting along the two sides of the parallelogram. Okay, so those two vectors are acting at one point. That is very, very important. Those two vectors are acting at one point. At one point. So I'm considering here. So this is one vector along this side. So along AB. So here you can take, this is A bar and B bar. A bar and B bar are acting at one point. Okay, at one point along the two sides of the parallelogram. Two adjacent sides of the parallelogram. Adjacent sides of the parallelogram. Understood? So both are acting at one point. That too, those two vectors are acting along the two adjacent sides of the parallelogram. Understood or not? And the resultant will be, the resultant is the diagonal of the two vectors acting at the same point. Acting at the same point. Understood or not? This is the resultant. So actually those two, the angle between A bar and B bar is theta. So if I took right, so A bar is this one and B bar is this one. So the angle is theta. This is the theta. Okay. So R bar makes certain angle with A bar, that is alpha you can take, and B bar with resultant with B bar you can take beta. So that's the different. So later we can identify the direction. So to find the direction of the resultant we will use that one. First, so this is, so A bar I am taking here. A bar. So this is A bar and this one is the B bar. A bar and B bar. Okay.